Hello class, and welcome to Notes 4.3b. You will notice this is a continuation of Notes 4.3a. I just felt like the last notes were getting a little long, there was a lot to cover, so I split it into two groups. What that means is we'll be jumping right into teacher example 4 without any vocabulary, anything new. We do still have our standards, we do still have our title, we just don't have any of the vocabulary rules or properties. So you can skip that section and jump right to teacher example 4, pencils down. Simplify the algebraic expressions. So now we're continuing with what we were covering with our exponents, but notice we have more than just a number or a letter and its exponent. So if I take a look here, the first problem I have negative 9 x to the 0 power. The negative 9 does not have an exponent, so I don't do anything with it. I simply leave it alone. The x, however, does have an exponent, so I need to do something. Now, if this was any old exponent, I wouldn't be able to do anything more because I don't know what x is. But because that exponent is a 0, I already know what I need to turn it into, even without knowing what x is. And of course, hopefully as you may have already guessed, I need to turn that into a 1. Okay, so again, the negative 9 does not have an exponent, so I simply leave it alone. Notice how I split it up here. The x to the 0 power, it doesn't matter what x is, that's always 1. Negative 9 times 1, of course, then is going to be negative 9. Okay, let's take a look at problem B. Again, the negative 3 does not have an exponent, so I need to leave it alone. The a has an exponent, and I don't know what a is, so I can't figure out what a to the 4th is. However, I can take care of this a to a negative exponent, because as I know, anytime I see a negative exponent, I need to turn it into a fraction. So I'm going to rewrite this, instead of a to the negative 4th, I'm going to rewrite it as 1 over a to the 4th. And now, of course, I can combine these two by multiplication. Negative 3 is the same thing as negative 3 over 1. So the negative 3 is in a numerator. So negative 3 times 1 is negative 3. And then, of course, you can imagine this having a denominator of 1. 1 times a to the 4th is simply a to the 4th. So I've combined them by eliminating that 1, because I just multiplied my numerators together. Okay, I'm going to go ahead and have you try this out. And number 7, watch out for that negative. Remember that turns it into a fraction. And number 8, watch out for that 0 exponent. Go ahead and try them out. Press play when you're ready to see the answers. Okay, let's go ahead and reveal those answers. Notice the 5 does not have an exponent, so I don't do anything with the 5. But the y to the negative 3rd, I need to turn that into 1 over y to the 3rd. And then 5 times 1 is 5. Nice and easy. Number 8, again, I don't know what the x is, but I know that anything to the 0 power is 1. So I have 15 over 1, which is simply 15. Okay, so hopefully you did all right on those. Those should have been nice and easy for you. Let's take a look at teacher example 5. Evaluate the expression x to the 4th times x to the negative 7th when x equals 6. Now, there's a few different ways to do this. You could combine these two even without knowing that x equals 6. So, if you wanted to, you could combine the exponents first and then plug in the 6, or you can plug in the 6 first, which is, of course, what they're going to have you do. So I have 6 to the 4th and 6 to the negative 7th now. I've replaced that x with a 6. Now, whenever it says multiplication, that means you're adding your exponents. So anytime you see that multiplication with a base and an exponent, if the bases are both the same, you can add those exponents. So again, I leave my base alone of 6, and I'm adding 4 plus negative 7. Now, of course, you already know that 4 plus negative 7, I'm going to be secretly doing something else, which is 4 plus negative 7, or secretly subtracting negative 7 minus 4. And I know 7 minus 4 is 3, and the negative has a greater absolute value, so your answer would be negative 3. Now, I've done a great job combining my exponents, but I'm not finished because I still have a negative exponent. And I can never leave my exponents negative unless I'm working with scientific notation. So of course I need to turn that into a fraction. 1 over 6 to the 3rd. And then 6 to the 3rd means 6 times 6 times 6. And I have 6 times 6 is 36, and 36 times 6 is 216. Okay, so that one's a little bit trickier. You do want to be careful there. Okay, let's go ahead and have you try this out. Remember, you are adding your exponents first, then simplifying. Go ahead, try it out, press play when you're ready to see the answer. Okay, welcome back. -2 plus 3. I'm adding a negative positive, which tells me I'm secretly subtracting, which would give me a +1 as my answer, and anything to the first power, of course, would simply be itself, so 8. This one's a little trickier. I have 2 negatives I'm adding together, so I know my answer is going to be more negative, n to the -17th power when I add them. And of course I can never leave my exponent negative, so I have to turn it into 1 over n to the 17th. Okay, and oftentimes you'll see it written in the directions it'll say use only positive exponents. What they mean is turn that into a fraction, get rid of those negative exponents. It's the only time you can leave an exponent negative is when you're working with a scientific notation. Okay, that was a really short one today. Go ahead, go on to the quiz. You may need to rewatch the video more. And if you're still feeling confused, I recommend you go to your textbook, section 4.3, and take a look at that lesson there as well. Number 1, evaluate the expression 6z to the -3rd. Number 2, evaluate the expression 8 to the -2nd times 8 to the 3rd. And number 3, evaluate the expression when x equals 2. So remember, you need to plug that 2 in for x to the -3rd times x to the 4th. Okay, good luck and have a great day.